Welcome back. In this video, we're going to be covering Go's concurrency model, which includes Goroutines, channels, and the for select loop. We'll just cover the basics here, but it'll be enough to get you up and started using concurrency in Go. Each morning, I make myself breakfast, and that includes making the coffee, some eggs, and toast. But I don't make them in sequential order, meaning I don't make my coffee and then make my eggs and then make my toast. I sort of start all three tasks at near same time. I go ahead and grind my coffee beans while the eggs are in the skillet frying, and then also while my toast is in the toaster oven. And I keep on bouncing among all three tasks until all three are done. And this is much more efficient than had I waited to just do my coffee, then eggs, then toast. And each of these tasks are independent of one another, meaning that making my coffee does not depend on my eggs being done. Now, this is very similar to how a computer uses concurrency. It just balances different tasks, so tasks A, B, and C, and gives each process some amount of time to go ahead and run whatever processes that they need to do, and tries to give each of the tasks equal time. And concurrency is best implemented when you have independent tasks running concurrently. Concurrency and parallelism are often confused. Parallelism includes tasks being run at the exact same time. This is more common in high-performance systems where time and speed are at a premium. But that doesn't mean that parallelism is better than concurrency, because concurrency is still a widely acceptable form of making our programs more efficient, even on lesser spec systems. So Go's concurrency model is probably one of its biggest selling points as a language. And there are two foundational pieces to it: Goroutines and channels. A Goroutine is some lightweight thread that performs some function that you have defined. Everything in Go is a Goroutine, including your main function. What makes Goroutines different than, let's say, a Java thread is that Goroutines are managed by the Go runtime, rather than the operating system that it runs on. In the example that I gave before, a Goroutine would be to make coffee, eggs, and toast all at the same time, or basically in their own Goroutine. Channels, on the other hand, are how we communicate with our Goroutines, where we can get values and write values to certain areas of our program such that we can perform actions with those values. In this video, we're only going to be covering unbuffered channels. In a future video, I could cover buffered channels. Here is a program that we're going to continuously build up in this video to demonstrate Go's concurrency. As you can see in the main function, we have 3 get HTTP responses, which means that we're just making HTTP get calls to the dummy JSON server to get users, then posts, then comments. Now, each of these tasks is dependent on the one before it finishing. So this will run, and the posts will wait to run until users has returned something. Now, API calls are slow compared to just in-memory processes going on in our programs. It is us literally reaching out to another server to perform some process and return a value back to us. So after we get users, posts, and comments, we then print out the runtime, so the total time it took to make these 3 API calls, and it should give it to us in milliseconds. Now, if you're curious about how to make an HTTP API call, that's a GET call, we have here a response and an error by using the HTTP packages get function, where we just pass in a URL. We panic if there is some sort of error. There shouldn't be in this program. It's very simple. Then we go ahead and read the response body from the API. Again, we panic if there is any sort of error, and then if there is no error, we go ahead and return the body back to whoever called the function. Let's go ahead and run this a couple times. I will do go run period. And we run our first time, we get 179 milliseconds. That's still pretty fast, but if we had larger, more complex processes going on, or maybe the server is located in a completely different country or part of the world, this could get pretty slow. If we run it again, because maybe the API server is caching our requests, we get 139 milliseconds, and let's run it one more time, and we get 145. So we'll probably bounce between the 130 and 150 more consistently if our program was running pretty consistently, but 145 milliseconds can be reduced if we use concurrency. Now let's start implementing concurrency into our program such that posts doesn't have to wait on users to return, and comments does not have to wait on users and posts to return. The first thing that we're going to introduce here is the go routine, and that is basically creating the thread so that it can go out and make the API call asynchronously while other parts of our program can continue. And the way that we're going to implement the go routine is just by calling go func. So this is going to be an anonymous function pre-appended with the go keyword. If you are unfamiliar with anonymous functions, I will go ahead and link the video right now. I encourage you go watch that before this video. So we'll have go func here, and we just wrap our HTTP call with it. But this isn't good enough because we have to call the function, and so then therefore we have to put the parentheses after it. And that's it. That's all you need to do to create a thread in a Go program. This is so much more simple in comparison to other languages that I've worked in personally. And we can go ahead and do the same thing for all the other HTTP calls we do. So go func, open up the braces and wrap it in there. There we go. That's 3 lightweight threads or Go routines that we can now spawn and go ahead and make asynchronous calls. Let's go ahead and run this. Go run period. And we get a runtime of 0 seconds. So maybe that was just a mistake. Let's run it again. And we get 0 seconds again. So something is going on here. We are waiting for some sort of response to be given back to us, even though that we ignore it. But what's going on here is that our main function is in its own Go routine, and we spawn 3 more Go routines after it. Now this is saying, I don't care when you return, I know that you'll eventually return at some point. And same for this Go routine and this Go routine. But what happens is that we never wait for the Go routines to finish and return to us. So this becomes, all 3 of these become their own processes, and so we continue to run the code, and the only other code that happens after these Go routines is just printing out the runtime. And so that's why we get 0 seconds. We immediately take the timestamp that we started the program, spawn off the 3 Go routines, and then print our runtime. So now let's introduce channels to get some sort of values back from these HTTP calls. Before we make all of these API calls, let's make 4 channels. First, we'll have our users channel. So I will call it users channel is equal to make, and then we give the channel type, and then what that channel is going to hold, or basically the data type that it will contain. So the users channel will just contain a string inside of it. And same for the posts and comments. So we'll have posts channel is make a channel that holds strings and fix the make. Then a comments channel that is also make channel that holds a string. Now I did say 4 channels, and our last channel is just going to be called the done channel. So here it's going to be done, which is make a channel that holds an empty struct. This may be confusing syntax at first. The whole entire point of this done channel is so that we know when all of our other channels have been filled up, and it will also cause our main Go routine to block until it reads a value from the done channel. We'll get into that here soon. So if we want the value from the user's API call, we need to assign it to the channel. Now assigning a value to a channel is not as simple as just using the assignment operator. Instead, we use arrow syntax. So I'll put users channel, and then I will use an arrow on the right side of the channel to indicate that the value from get HTTP response will be put into the user's channel. Similarly, for all the other ones, posts channel will contain the response from the posts API, and lastly, the comments channel will contain the response body from the comments API call. Now it is always good practice that whatever function is writing to the channel, that once it is done with that channel, the channel is closed. So after we're done writing to the users channel, we'll just call close users channel. Same goes for the posts channel, so close the post channel. And lastly, for the comments channel, we'll close that out too. Now we are one step closer to completing concurrency in our program here. We still have the done channel that we need to do something with. For now, we'll go ahead and comment out the done channel, but we'll come back to it here later. And let's go ahead and get back the results from all of our channels here. So first I will have users, and that will be equal to reading from. So we put the arrow on the left side of the channel. So users channel. Similar for posts and comments, we initialize a new variable that is reading from both channels, which I need to fix this last one. And we're getting a compiler error because we haven't done anything with users, posts, or comments. So right below the runtime print, we will go ahead and print out just the first rune of all three of these variables so that we're at least serializing the responses back from the API. So it will just be users sub-0, posts sub-0, and comments sub-0. Let's bring up the terminal and run the program again. So go run, and we get 110 milliseconds. We'll run it again. This time we get 127. And lastly, we get 107. So we've reduced it from that 130 to 150 millisecond range, but we're still not quite at full concurrency in our program. And that's because we're using unbuffered channels. Let's break down how this program is working again. We do have concurrency effectively running for all three of these Goroutines. The main Goroutine spawns off these three sub Goroutines to go get users, posts, and comments. We don't have to wait on users to finish up or posts to finish up for comments to run, and vice versa for all the other combinations. But when we go to read from these channels, so you can imagine that our program just goes off into its own little sub program for all these Go functions, and then we return right here to synchronously run the rest of the program. We actually block at the users channel when we try to read from it. And what do I mean by blocking? When you're using unbuffered channels and you try to read from an unbuffered channel that has no value inside of it, your program will block until there is a value that is entered into the users channel. So essentially, if users channel does not return before post channel or comments channel, we will hang here at users until there is a value inserted. Similar goes for the post channel and the comments channel. So how can we make this quicker? Like such as, what if post channel gets a value put into it before users channel, or comments channel gets a value put into it before posts or users? And that's where we're going to start using the done channel in a for select loop. So go back to the top of the program and uncomment that done channel. And what we'll do is we'll spawn a fourth thread that's going to handle when all of these threads or all these Goroutines are finished. So make our last Goroutine with go func, open up the braces, and this is where we're going to do a for select loop, which is sort of a new concept. So I will have a for loop that just runs. So it's technically the while loop of go if we give no condition to it. And then we'll have a select statement within it. Within a select statement, it's very similar to the switch, in which we have different cases. So I will have this case, the very first case, which we'll try to read from the users channel. So I will do case users, or case val okay will be equal to reading from the users channel. Then we can open it up with the colon, very similar to the switch statement, and we'll do an if not okay check. And if something went wrong, then we'll go ahead and make the users channel nil and continue with the for loop. If everything was okay, then we'll go ahead and assign users to some sort of value. So up here, we'll go ahead and declare that users variable. So var users string, and back in the case, we'll just assign users equal to val. Then we're going to do something very similar for each case. And don't worry, I will explain how this is working here very soon. So let's go ahead and finish this up. So case val okay, when we read from the post channel, make sure that this is an okay read from the channel, and if it's not, then we go ahead and make the post channel equal to nil and continue with the loop. Otherwise, we need to make a post string too, so var posts, which is a string, and we'll also make our comments one while we're at it, so var comments is a string. Then we assign posts equal to val, and one last time for case val okay for the comments channel. If not okay, then comments channel will become nil, and we continue with the function. Otherwise, comments gets filled in with the val. After that's all said and done, we will close that done channel. So what's going on in this for select loop? A for select loop, or let's really just focus on the select portion of it. When a select is running, it is going to randomly select a case that is contained within the braces and try to read from that channel. So here it will randomly select the users channel or post channel or comments channel, and we can read from it. When you read from a channel, you don't know if it's been closed or not unless you use the val okay idiom. When you just read from a channel, such as if we did not have this okay piece of it right here, you automatically get the 0 value from that channel if it was closed. So the only way to tell if a channel is closed is by using the val OK idiom. And so if OK is false, that means that the user's channel was closed. So therefore we can set the channel equal to nil. Now, why would we do that if we already have the OK idiom saying, I know that this channel is closed? Once we know that the user's channel is closed, then there's no reason for us to ever try to read from it again. Prevent our select statement from continuously pinging that channel. You can set it to nil. So once the user's channel finally returns back to us, this case essentially disappears and it will only check for the post channel or comments channel. And it will perform the same action on if the post channel was closed, then we set it equal to nil and continue on with the loop. Once all of these have been read from and the values are filled in, we need a way to exit that for loop. So in accordance to what I had just said, if we are no longer reading from any of these channels, that means that they must all be nil. So we can just make our condition for the for loop to exit. So while one of these is not nil, we will continue running. So while post channel is not nil and while comments channel is not nil. And again, since this is a Goroutine in an anonymous function, we need to call it, and we also need to fix this read right here. We can go ahead and delete all these reads below. And lastly, we need a way of knowing that this Goroutine finished up reading from all those values. So we just need to do an anonymous read from the done channel. And now we have finally implemented complete concurrency in our program. Let's go ahead and save, open up the terminal, and run the program. So when I run, I get 182 milliseconds because I haven't made a request to the server in quite some time. So let's run it again. And we get 101 milliseconds, 116, 144, 93, 162. So it's kind of bouncing all over the place, but my internet is fairly weak right now, so I will pass it off because of that reason. But we have gone ahead and completely implemented a concurrent program here. And so let's cover this one more time of what we did. We made 4 channels, 3 channels for all the API responses and 1 to signal once we are done. Then we spawned Goroutines using Go and putting what our business logic inside of an anonymous function. And then once we get back the response, we close that channel. And remember, to write to a channel, we use the arrow syntax on the right side of the channel. Then we created variables to hold the strings that we got back once we read those channels. Then we have one last Goroutine that is a for select loop that exits once all the channels that we have are nil. And using a select statement, we read from the channels, which it randomly selects a channel to read from. And if that channel is closed, then we go ahead and set it equal to nil, so that case no longer runs. But if that channel was not nil, then we go ahead and assign the value over to a string, and we repeat that for the post channel and the comments channel too. And once our for loop completely exits, then we know that we're done. So then therefore we can close the done channel and we sit here and just block and wait for everything to be done. And once that's done, we print out the runtime to the screen. And that's the basics of concurrency in Go. Remember, all your tasks have to be independent of one another in order for your program to become more efficient using concurrency. In future videos, we can cover sync wait groups, mutexes, and other various parts of Go's concurrency model. But for now, if you made it this far in the video, I want to thank you for watching, and please consider liking and subscribing. I'll see you in the next one.